Hello, everybody. My name is Matthias, as introduced by Bibiana. Thank you for that. I'm here to tell you a bit about the work we've been doing for, I believe, 10 years or even more. And the goal is to, our mission is to connect the unconnected. So trying to get people on the internet that don't have access for various reasons, and we get to that. Quick outline. I'm going to talk a little about very quickly about Fraunhofer, just to give you an idea, because here we are at a more university setting and Fraunhofer is a bit different. So I'll just give you a quick idea on that. Then I really want to talk about WiBACK, connecting the unconnected, communication to enable services. And we'll see it's very critical to actually have a service and the need before we actually talk about communication. There's an introduction. I talk a bit about the idea of making all this open source and what that entails. I talk about use cases and I talk a bit about costs of funding of some of those projects, because we want to be more cost efficient, but we are not free. And in the end, I have a quick summary and I would like to get some feedback from you guys. I took out most of the technical aspects because I think this is not the right audience here. I think you have more interest in like the problems around it. And actually, you might be rather the experts on this, not me. So it's a new experience for me to explain to you lessons learned for me that might be quite common for you. So I'd be really interested in feedback on this. Okay, very quickly, Fraunhofer. The guy was a researcher, an inventor, and he also started his own company to kind of market what he did. And this is something that Fraunhofer wants each of its employees to look into, do something applied, like do something that has a more near-term concrete value, not plain research, like write a paper, forget about it. I'm not going to say more about this. There are tons of Fraunhofers you might have heard about us, typically associated to a university. I come from St. Augustine. That's a campus with a different history. If you go across the river, a few kilometers up the hill, that's where we are located. Just to like stress, different to a university, we have some basic funding or base funding. Most funding is from external research grants or something, but we have this requirement to get some funding from so-called industry, and that should kind of show or indicate that we are doing something someone has a monetary interest in. So that's kind of the tension we have. We can like apply for a lot of research funding. We might have enough money to pay our people, but we are not meeting the criteria on actually getting income from a company who has real interest in this. So that's an interesting tension in Fraunhofer and also for the topic I'm talking about, because that topic does not have much money behind it. And that's, we basically see that's why there is no connectivity. So as I said, this mission is this connecting the unconnected, and important here, we are trying to make villages smart. So I'm sure you heard the people talking about smart cities and the new cool feature you can do in a smart city. You sit in front of a fountain, you watch an 8K video and whatever is cool. Well, there are up to 4 billion people in villages that have zero internet, nothing, okay, nothing. Either not there or not affordable. And that's our focus, okay, not smart people in the city. We want to go to the villages, and here typically the goal is to be an enabler for services that need communication, like whatever application you have on your phone that would need communication in the first place. Even the United Nations a while ago declared internet access a basic human right, but to actually get there, it's a pretty wide step. On this map, you see the city of Medellin in Colombia, but it could be any city in the world. So wherever you go, a larger city, you turn on your phone, you have internet. It might cost a bit more, it might cost a bit less, it might be a bit faster, it might be a bit slower, it might be a bit flaky, but there's internet. Whatever you're used to, you can do. And then in many cities, even in Germany, you go out into the countryside and you notice, oh, no internet or very flaky internet. Like take a train to Hamburg and somewhere in the middle, suddenly you notice, oh, blank. But here we're talking more about the stationary networks, like the small towns, villages around it. So the goal is to bring those people online, and what are the challenges and what can we do about it? To back up the numbers a bit, I used to say 4 billion unconnected. I think now it's more about 3, depending how you count it. If you count technically not connected or due to financial reasons not connected. The ITU here, they come up to they sum it up to about 3 billion, but it is still a relatively big number. So why is this? And this is one of the slides that we learned over time and where you actually might know more than me. I usually call it the economics of connecting the unconnected. And in our experience, it's kind of like you're managing a very limited financial resource. There's no technical reason why we could not connect anybody. It's just a question of cost. If you live in a desert with 100 kilometers, nothing around it, it is just ridiculously expensive to get you connected, but we could. And so the question is, what's the issue here? So if you look on the y-axis, this is qualitative, okay, no quantitative numbers here. You see the costs to an operator to provide access or service to a customer. And you also see the revenue an operator can make from providing you internet, basically. On the y-axis, you see the population density of the people. So we go from urban, like here, to suburban, to rural, to really remote. And what you typically notice is the further you go out, you reach this point, this break-even point where the operator doesn't really make money anymore. So it costs him the same as he makes money from the customers. So they don't have any intention to go out any further. Now you can force them, you can subsidize it, whatever, but like without that, they wouldn't go any further. So what we have to do, or anyone, doesn't matter how you do it, we have to bring the costs down so that we can try to go out further. As I explained before, it might not be possible to go out all the way to the end because at some point you just can't make the numbers match. So before talk about the technical stuff, there were questions that I over time wrote down like this. What is a basic need? So if you talk about someone should have access to the internet, what does that mean? Is it a few hundred kilobits like we used to have with ISDN? Is it a megabit when DSL started? Is it 4, 10, or now you can buy up to a gigabit in Bonn, I guess, which you never need, by the way, but you can get it. And then if you talk about other countries where people don't have access, how much should they have? What is fair? Also, if you compare rural versus urban, in rural areas, you pay often a lot more for the same bandwidth, like compared to urban areas. What is fair? This is out of my expertise. How do you distribute those costs? Should people in the city pay more to subsidize people in the countryside? Or do we just say, well, move to the city and then you get your internet? And often there are very prohibitive regulatory issues. Like on one hand, the government says, I want my people connected, but then they put up huge fees for doing this, like for renting spectrum or for getting access to fiber. So it's often very contradictory, the goals and the need. And often there's also this, well, my brother owns this company, so I don't want you to be a competition. That's also something that happens quite often. And also, what you have to keep in mind, you build up infrastructure, you build up a network. You want to make it cheaper, but you build it up, it costs money. It's not for free. It's not like it comes out of nothing. So then when this is cleared, and I think, as I said here, you are the experts, we come more to the technical aspects. And the goal here is to, as I said, we have to come here. So we have to reduce the CAPEX. Because the capital expenditure is like the money you have to invest to build a network. So buy equipment, buy poles, whatever. And the OPEX, that's the operational costs. How much does it cost you to run and maintain it? The people that maintain it, stuff that might break, maintenance, whatever. And we want to reduce this while still provide a good service. And notice I say good, not the best. Okay, and we come to that later. And we do this by an idea and approach we called inclusive innovation. What does that really mean? It means we want to build technologies for a lot of people in not so rich areas. So you can read the 2 citations yourself here. What I want to stress is Our goal is to build a good performing, sustainable solution at low cost. If you, for techies or for pure researchers, if you want to invent something new as a techie, for example, you would look at existing stuff and you would say, okay, I want some new features, some new invention. I'd be a few % better than someone else. And then you test it, you put it together, you do some measurements, you publish it and say, hey, I'm 10% better than someone else. It might not be applicable, it might not be affordable, so basically it might not be used for a long time. The goal we have is to say we take features, value, and we have to consider the costs, and we have to maximize that equation. And that might mean in the end, for example, here, we might use a lightweight 4G network instead of the latest 5G or 6G, what is now being discussed in research, just because it's cheaper and it does a very good job, not necessarily the best job. And that's basically how we look at every component to say what's good for the money and what works in the target area. So we upfront say we are not building the best, okay? If you get the latest high-tech 5G network, it'll be faster. It just costs you 10 or 20 times the money. If you have the money, okay, fine, take it. If you don't have it, we need a different approach. And that's what we're advocating. And we have to often tell this because if you write a paper with this approach, you might get it back and people tell you, oh, it's old. We know it. And you have to really explain, listen, the combination of value and cost is important. And you have to evaluate the whole thing. Okay, not just that someone did something very specific before and showed it works or works not. It's the combination that works. Yeah, what's the problem with connectivity in general? And for smart villages in particular. Typically, when we talk about networks, we talk about 3 different segments. There's a backbone that's typically in all countries, fiber lines. This is now Germany here. Hello? Okay, here. This is now Germany here, but it doesn't matter. Even in most countries in Africa, the big cities have fiber connections. The problem is more how you get to it. There might be regulatory or money issues, but they typically exist and they are being built. So that's kind of taken care of, that's happening. Then you have the so-called last mile or access. This is how your phone gets connected. At home, that's your Wi-Fi access point. If you're on the street, that's the cell phone network. It might be your DSL modem, something like this. Technology exists. So we said, okay, that's fine. In different price ranges, you can get all this. There's not much to do. Where we found out most work has to be done is the segment that's called backhaul or transport, depending who you talk to. And that's that part here where, stay with me, where you basically go from the fiber into the villages. So you might remember my introduction slide. You have your city that has internet or has the fiber connection, and then you have those small towns or a business or a school or something, and you want to connect them. And that's what you call backhaul. Then when you're in the town and you turn on your phone, that's what's called access. So what our work is about is getting connectivity into those places in the area, okay? So there is a bit technical stuff. If you look at all the keywords, when we started with this, we were looking into all the different technology options issue we'd have to tackle. And then we kind of developed a key set of features that our network would have to provide at a technical level. First of all, everything would have to be low cost. I explained that before. Plug and play, you might know this term from computers in the 90s or something. You plug stuff in and it works. You don't have to configure things. Quick deployment, it should be easy to roll out a network. It shouldn't take you days or ages to go from step to step. Low maintenance, you should not require to visit your deployment sites every day or have someone out there who is knowledgeable and can walk around and check things because the person often doesn't exist, and he might be pretty expensive. You need to run off-grid. So typically out there is no access to a stable power grid. It might be there and it might work, it might not work. So you need to be able to run on solar. it's easy to do, but the more power you need, the bigger your panels are, the bigger your batteries are, the more costs you have. So it also means you should be low power. High throughput, low latency are typical technical criteria. High throughput means how fast is my internet, and low latency means if you're gaming, how quickly does the network react, or how quickly does your app react. And that's important, for example, when you place phone calls or have a video conference, you don't want to have this huge lag, because then you feel more like walkie-talkie instead of having a conversation. And quality of service is a wide field. Basically, for very high-level view, it means I want to be able to make a phone call while someone is making a download. The download should not interrupt my phone call. That can go much deeper. And we try to kind of pick out the SDGs we are addressing with this work. So of course, the core SDG here is the communication technology for the unconnected areas, but essentially that acts as an enabler for others, such as education, work economic growth, and reduce inequalities. And I'm sure you can name some more. A lot of those SDGs need working communication underneath to be actually, so you can implement them. So to give you an abstract idea how such a network could be set up, you remember Medellin, so you have your internet, you make a plan, which villages would I like to connect, where is there a mountain in between, and so forth, where can I actually see my destination? That's very critical for us, because it's wireless. And you would set up poles, you turn them on, you kind of form connectivity among those poles, and then you have access in the buildings. And people should enjoy more or less the same service as they have in the city. It might be a bit slower. So the 8K video you get in the city might be an HD video or even less at home, but you do get a video. Okay, so you can see the same content. What happens if the network breaks? If something breaks, it should. Oops, the animation seems to be broken. What you should see here, if this fails, this and this link goes down and the traffic goes the other way. So we have some redundancy built in, so that if node runs out of power, is stolen, is damaged by rain or lightning or something, the network can still be operated, and also that should be automated. Very quickly, why are we cheaper than, or why do we think our solution is cheaper or more sustainable than others? You can buy cheap wireless equipment. You might notice if you connect a building, you can buy like point-to-point Wi-Fi equipment, costs you 100 euros or something. The problem with this is there are a lot of configuration steps you have to do. Don't need to go into details, but typically you have to configure this all manually, which means you have to know what all those parameters actually mean. It's relatively easy to do for 2 devices, like from here to across the street. Becomes interesting if you have 20 or 30 of those and they need to be coordinated. So one of the things we are trying to do is we're automating as much as possible of this configuration and build in all the knowledge to do this efficient or properly. So actually the network works at the best performance you can achieve given the situation. And of course, never trust your studies that other people do, but we try to break down those steps that are required to build such a network in small aspects and try to assign a difficulty level. Do you need an expert, a normal user, or can basically anyone do it? And we try to compare our solution against cost-effective solutions on the market. And what, of course, depending what numbers you put in there, but we also ask external people. And typically what comes out is we need a lot less experts for the network setup. And that's critical because those experts often don't exist. And you can buy a lot of equipment, but you won't find anyone who will set it up for you. Or if something breaks, then maybe the guy lives in the capital, like we have a network had a network in Tanzania, the guy lived in Dar es Salaam. The network was 2 hours by flight away plus 3 hours on the car. Okay, so that's doesn't work. You need something that the locals can maintain. And what we should need is someone like a housekeeper with some basic understanding how to change a light bulb, how to fix a power wire. You tell them simple things, take this box off, unplug the cables, put the new one there, put the cables back the way they were, and it should work again. Or if the antenna is broken, take this one down, put a new one, put it in the same direction. The relatively simple tasks you can teach people. And that's basically the key feature here. And over time, this saves you cost and time on expert personnel. And as I said, you don't have them usually on site. That's why this is critical. A bit different topic to touch, costs in general. Depending what network equipment you buy, like if you buy Wi-Fi, it's pretty cheap. If you talk to people who want to set up a mobile network, 4G, 5G, something, then you notice there are ridiculous fees on this. And there's a lot of software that is open source. You can basically just use if you want to. And open source is also the way we want to go with our solution. It's a bit tricky for me to get this done for other reasons, but that's the goal here. And you might have heard that before, open source does not necessarily mean free of costs. It means free to use. It means I basically don't charge you any fees to use it, but it doesn't mean I have any obligation to support you. So you can take what's there. If you know how to use it, it's okay. I might not support it. I might not do anything. So even if I say it's open, and if it's a larger project like this, yes, you could use it if you understand it, but at some point over time, new features might come in, bugs might be there. If no one overlooks the whole thing, it'll just break apart. So even if it's free, what we are trying to find out is how we can make it open, but how we can find some funding for a group of people to maintain the whole thing. Might not be us at Fraunhofer, might be someone different, but the person who does it or people who do it need to live from something. So there needs to be some money for this. Of course, the typical thing is licensing fees, but that typically contradicts this idea of technology transfer, where we say you can do it in your home country a lot cheaper. And enforcing license fees is an extra task. Instead of just say, here, just use it, I have to implement some infrastructure to say, okay, you used 5 of those, I charge you, I don't know, whatever on your credit card. It's extra effort, and it's hard to control if you're outside in somewhere. So open source, there are others, there are foundation models, like you might have heard about Raspberry Pis, those small computers everybody uses to hack stuff. If you buy one, a few cents or whatever goes back to this foundation and they maintain it. Something like this is might be the way for us to go as well. Early adopters, I said we've been doing this for more than 10 years already. So we had a couple of deployments worldwide, and we learned a lot from doing so. So we are technical people, so we basically said, okay, there's a technical problem, let's find out what the issue is and fix it. So I think my colleague went in 2010, he went to Zambia. We knew some people there. They took us out to a location. There was a hospital. They had internet via satellite, and they wanted to connect a school around it and something else. Said, okay, let's have a look what they tried, what the issue was, and see how we can solve this. That's basically how we learned about, lack of knowledge. We need to automate things. It needs to be simple. It needs to be cheap. So we learned a lot, which if you come from above, you might actually know this. You might have known this before. So our first deployment was in Italy, was much closer. Money was not so much an issue. We could do a really nice test. They used it for a long time. Then we got contacted from people in Valledupar in Colombia, which is still our partners. And they were looking for a solution to implement e-learning in the countryside. I'll show you a slide later. We had an ISP in Germany who provided internet north from here, the border to Holland, very flat, not many people, a few farms. They didn't have 5-6 years ago, 9 years ago, they didn't have much internet there. And he basically found a way using our approach to provide internet there. We've been in Bunda in Tanzania, that's southern end of Lake Victoria, tried to connect a few schools. And here I can tell you a bit about our experience with development cooperation, if you don't know exactly how it works, or if you have good intentions, but you don't see the whole picture. might not work out so well. Then we had colleagues in Portugal who went in a lot of those Portuguese-speaking countries in Africa and tried to demonstrate the technologies to the national regulators. I think there was quite some interest, but then there's the money issue again, I spoke about before, and we have a couple of test networks here. For example, you might know Freifunk or so, or RoofNet in other countries where they have public hotspots you can connect and you get internet. They had some very remote locations which we connected on some old castle or something, and you could get internet, just as examples. Okay, this slide is a bit technical, so I don't really want to go too much here. I spoke about CAPEX before, so the costs of equipment you have to buy. It should be low cost and low power. So we use Wi-Fi radios. We don't use the really cheap stuff that's in the home devices. It's a bit more expensive, but still very cheap compared to other commercial equipment. We use Raspberry Pis as the base board for our system. We try to be very energy efficient because, as I said before, small solar panels, small batteries mean in the end, smaller or more lightweight pole. So this is a pole that's currently being set up in Colombia, but you see on pictures in Africa, it's the same thing. You have battery power converters, you have solar panels, you have antennas for access, this specific Wi-Fi devices that reach a bit further into homes. And on top, you have the WiBACK antennas that go to the next pole and the next pole and so forth. On the OPEX side, use of unlicensed spectrum, you don't have to pay for license fees, has some technical implications, but you can manage this out there and it makes it cheaper. Zero maintenance, I managed. The open source idea I also told you. So everything is tailored around cost savings and still trying to make it work in a good way. So I told you on top of the pole is a so-called WiBACK node, a device that receives data and sends it on and provides access. What's basically in there? It's a baseboard you can buy off the market. So it's nothing we did, costs about 100 euros. Couple of those antennas also cost something like a few €100. Those a bit more expensive Wi-Fi radios cost you something like 30 euros each. You have a case, costs you 50 each. Then you have those access antennas, they cost you probably a bit more, 100. So in the end, the whole thing is 1,000 something euros, okay? Plus the pole, you will later on see the pole is the most expensive thing. A quick look, you have a management UI, so you can operate the system, and here you see a network, you have a controlling entity in the middle, and they set up towers, they formed a ring, so they have some redundancy or failover capacity. If like this node fails or this link fails, everything else is still connected, because otherwise, for example, if this thing here goes dead, also everything behind it goes dead. So you always want to have some kind of ring around it. A few examples. This is the first network in Colombia in 2014, I think. The idea was that the company who contacted us, they were building an e-learning solutions where the students would learn something during the day at school, and then they played a game where they were asked questions about it, and they had to kind of remember what they learned to continue to advance in the game. It was an online game, so it worked in schools in the city where they had internet. It didn't work outside in the countryside, like in those places. So they used our technology to get those schools connected. That was the first contact, and that carried on until today. And at the moment, they are setting up 3 larger networks. Other example was Tanzania. It was a very, well, I still think it was a very good goal, but we did not really ask all the questions to the end. There were colleagues from Sweden who got us in, so here's this Lake Victoria, here is Serengeti National Park. Somewhere the entrance is somewhere here. There's this town called Bunda, it's a bit bigger, had a proper school with educated teachers. And there were a few towns along this road. There were also a few schools, but from what they told us, no really educated teachers, was parents teaching the kids. So the idea was connecting the schools so the kids would have access to a real teacher. So we actually, after I think we've been there 4 times, we set up the network, it worked. We had a session in the end where kids remote in, I believe, somewhere here in the middle somewhere, I think Mayolo, were gathered around a laptop listening to a teacher telling them something about math. It's Swahili, I didn't understand it, but from what they told me, he was telling them something about circles and squares and triangles. And it was quite amazing how the kids responded to a real teacher. The guy was really good, had a good presence, and like he caught them and they were all like really looking at him, a completely different experience from, I guess, what the parents would be able to provide. It worked, we left, and I think after a week we learned, okay, the first thing breaks. Because we said, we bring equipment, you guys get batteries. When we got there were no batteries. Then they bought some old car batteries on the street, and car batteries are not good for solar. You can charge them 10 times and they are dead. And a lot of those things happen. So we looked at our thing, okay, we built here a good network, but we didn't look much at the surroundings, which I guess if you think about it, yes, you could have, but when you start, you know, okay, there are people doing something. There was UNDP support, they paid for the towers. You know, they built those 30-meter towers. As we kind of thought it would work. We didn't really ask too much. And I learned by now, if we go somewhere, we ask a lot first if like the whole thing makes sense. Otherwise, you know, you have a network, but around the surroundings fail. But yeah, it would have been really nice for the kids. Okay, today, as I said, the same company in Colombia that contacted us a long time ago spent years, I think, applying for money to, I think it was a public, and you guys might know better. Time? I'll be done in a second. Applied to public tenders for bringing communication in post-conflict areas. They won those tenders and they're using our technology to build such networks. So we built those towers. It was quite painful for them to get them out in the rainy season in Colombia last year. Everybody kind of gets a wireless access point, has a cell phone, and here's one of those devices that gives access in your home. This is how such a network looks like. Okay, time. One very important slide also sums up a bit what we learned. There are different roles if you want to do a project like this. You know, someone has to provide equipment. Of course, you need users. Someone has to pay for all of this. And you need someone local to really tie everything together and do it. Buy equipment, talk to the users, set it up, be there if something breaks. Otherwise, it will fail. This is very strong experience. If you don't have all this together, it won't work. That figure you've seen, just a quick breakdown on costs. This is probably not fully accurate, but if I told you before, this WiBACK equipment costs about 1,000, this should be more like 10%. A pole like this in Colombia, they told us, is about 10K US dollars. And I heard a similar number in Tanzania. I don't know if it's correct, but it's the numbers I heard. And I'm not sure what exactly that includes, but a pole is the most expensive thing. So you need to plan the network so that maybe you don't need a pole because you can use a higher building or a stable tree or something like this. And then there is solar and an access solution. Yeah. What you can take from this is every deployment is different. So it's hard to give a concrete number. What does it cost to connect 10 villages? Because it depends on landscape. Do you need a pole or not? All kinds of things. It's really very difficult to give you a concrete number. And I think that one we skip for the sake of time. As a quick summary, I think we have a solution to connect the unconnected. To enable services on top. So before you think about a network, you need services and a need. The goal was to make it plug and play, cost effective, use proven concepts. I didn't talk much about this. There's more technical issues. We use similar protocols a network operator uses. So we did not invent everything new. We tried to see what's there and try to adapt it probably and said, okay, there are extra features that are not needed. Can we take them out? But it is not like a completely new idea. And open design, open source, local production. We want people to be able to build this in their home countries at their cost structures. You know, assembling it here or ordering stuff from China, assembling it here, shipping it anywhere in the global south is just ridiculously expensive. So they should be able to do it themselves. And with that, I would conclude. Thank you for listening.